Alright, it's time for the last video of the prototype version of the helmet electronics for the Daft Punk Gold helmet. So the purpose of this video is to document my construction before I take it apart and shrink it down. Obviously all this stuff cannot fit inside of the helmet, so it's got to be mounted on some kind of perf board and soldered in place, and connectors are going to be used and everything. I added this rotary encoder over here, so let's just turn this thing on. The rotary encoder is going to be used to switch between the modes. Right now, for demonstrational purposes, there's 3 modes. So you see in the first mode it's red, and then you turn it, and the second mode is green, turn it, and the third mode is blue. You turn it too far, it goes back to red. We've got our, we'll just start at the beginning. The audio comes in through the electric mic and goes through a, what the heck was the name of that thing, 2N3904. From there it goes directly to one channel of the MCP 3002 ADC, and it also goes directly to the audio input of the MSG EQ7 chip. The MSG EQ7 multiplexes it and peak detects it, sends those readings over to the other channel of the ADC. The ADC is read by the P8X32A microcontroller, which also controls the transistors for the LEDs inside of the RGB encoder. And we've got some resistors over here for the actual encoder. Inside of that knob there's an encoder. So just 2 wires reading that. And I have a couple routines in here just for show. The programming's not done, but we're at a point now where we can move it to the helmet and then start programming it from there, which makes a lot more sense. The mode that we're in right now is called EQ mode. So this is a spectrum analysis where the upper colors up here are higher frequencies, and then down here you've got lower frequencies. It's also adjusted so that it's a combination of looking cool and functionality, because if it was just the actual spectrum analyzer, there would be a lot of LEDs that don't light up. So it kind of looks like the helmet's broken when that happens. So I turned up the sensitivities on a lot of these quite a bit. My voice definitely does not cover the full spectrum range. It's probably, centered right on 150 hertz or something, but anyway, it is actually sort of representing the audio spectrum. It's a close representation, but it's not entirely accurate, just because it actually looks broken when it's accurate. It doesn't really work well unless you've got some really loud music, and even then it's kind of weird. So that's what I ended up with for now, and like I said, the programming part isn't over yet. This is just the part where we move all of the electronics from breadboards to perf board. So here's mode 2, which is going to be pre-programmed routines. It's going to flip through a few of them. And then we've got mode 3, which is a blue knob. And this is your regular old VU meter. So the louder sounds are, the more LEDs light up. As this happens, there'll probably be some color changing going on. This routine right here, you don't really need RGB LEDs. Everything's kind of a fixed color turning on and off. So you would want to, program stuff in there to take advantage of the RGB LEDs and not just use solid colors. So that'll happen, like I said, after all this stuff goes into the helmet, then the real fun begins. And I have here a cheat sheet for the LEDs. This basically shows the address of the LEDs. So each RGB LED is one number. So you can see we have 8 we have 8 rows, and then we have 4 columns on each side, so it's actually 8 rows and 8 columns, but each side is split, so you can see the split there. So if you wanted to turn on the LED in this corner right here, the first LED right here, that would be LED 00. And the reason they read from right to left is because if I want to use some type of variable to control them, I want the physical effect to show up from right to left, which would go from the outside of the helmet to the inside of the helmet. And that's also the reason why it goes from bottom to top, is because we want the LEDs to go primarily from the bottom to top. You know, it can be programmed to go the opposite direction, but for the most part, it's going to go bottom to top. So that shows that, and then down here it just breaks down the fact that each row of 4 LEDs, each LED has 3 settings applied to it: red, green, and blue amounts, which are here 0 to 255. In the code, it's actually hexadecimal. So that's pretty much it. This is probably the last time you'll see it before it all goes into the helmet, and then everything is working. Because the perf board stuff, I don't really know if I'm going to share that. It depends on how well it comes out. I usually like to hide that stuff in the corner somewhere, but we'll see what happens.